Okay, am I audible now? Hello?
Yes, you are. Yes,
Yes,
you're
yes.
audible.
Oh, awesome. Okay, so we're talking about bit manipulation, right? So I said that before we dive into bit manipulation, let's understand the architecture behind bit manipulation. I mean, what's inspired bit manipulation? Okay, what inspired bit manipulation? So if we could understand that, it will be easy for us to understand the bit, to it will be easy for us to understand how bit works and how to manipulate bit itself. Okay, how to manipulate bit itself. Now, so I said that now, please, if you can see my board. Oh wow, I'm not let me just share my screen. I
Yes.
thought I was sharing my screen. Okay, can you all see my screen?
Yes.
So you can see my screen. Please do it with the board. Okay, so now let's understand the architecture behind, or the reason behind bit manipulation. What inspired bit manipulation? Why are we manipulating bits? What for? Okay, now, you know our program, like our system, like all our machine, all the machine in this life or on this earth only understand ones and zero. Okay, machine only understand ones and zeros. Okay, that's all what your machine, my machine, all understand. You don't understand any other thing apart from these ones and zeros. Okay, that's only what your machine understand. All right, so now, you know um if you are writing a program, or the way I will be writing our if else statement, our what's it called, our array, all those stuffs, those are in higher language. Okay, that's why we call them higher language. Those are in higher language because we are writing it in our own human readable format. The way we human being understand, we are writing it the way we understand. Okay, and we want our operating system to understand the same thing, and our operating system only understand ones and zeros. It does not understand the if statement, the return statement, the array, the linked list. It doesn't understand all those stuff. Okay, it doesn't understand all those stuff. Okay, so, and the only thing you understand is just the ones and zeros. So in C, that's why we compile our code into machine code, and I show us if four stages that your program will go through before that will go through before the executable file. Okay, now I said we have the preprocessor. The preprocessor. We have the compiler. We have the assembler, and we have the linker. Then the linker will now link it to what? To our to um the linker will link it to um an executable file. Okay, that is on Linux it is a.out, and on window, let me just separate it, let me just put window, it is what? Dot slash aexe. Okay, on window, while on Linux it is this, right? Then put Linux. Okay, a.out, and on windows is a.excel, as execute. Now when you compile your code, you write your program. I'm done writing my program in the way I understand it. I'm done writing my program, maybe the way I understand it. Then the first stage your program will go through will be the preprocessor stage. Okay, the processor stage you just scan through your code, check your header file, what you are trying to to import, your prototypes, your main.h, your stdio.h, all those include directory. Okay, we scan through it and check if everything is working fine. So if everything is working fine, then compiler will now compile them. So when compiler is compiling them into an assembly code, okay, into a machine code, okay, assembly code. So compiler, oh sorry, so compiler will compile them into machine code, and that's my focus today. Machine code, which is what? Our ones and zeros. Okay, our ones and zeros. Okay, so now I've written my program the way I understand it. Then let's assume that I wrote a program like this. Let's assume that I wrote a program. Where can I put this? Let me put it here. Let's assume I wrote the int main, main. um Let me do this. Let me just say print f, um I love programming. Okay, programming. Okay, then I close it. Now this is my what? This is my Look at it. This is my program. Okay, print f, I love programming. Now I want the first thing is that my preprocessor will scan through my header file, as I said earlier. Then this compiler will now compile this thing into assembly code. Okay, that's the work of assembler here. The assembler is just like a tool that we use to compile an assembly code. Okay, that's why I put assembler. While linker is one that link everything together. I mean that link your ones and zeros. So once this compiler compile your code into your program into machine code, it will be ones and zeros. So in the interpretation of your operating system, will be for this printf I love programming, might be 111 000 000 111 000 111 000 111 000. Imagine. So this is how I'm just assuming here. Okay, this is how your operating system, your machine process this printf I love programming. So this compiler compile them into machine code. So I compile this I love programming into this machine code. Look at it. Okay, so it has been compiled into machine code, and can also call it assembly code. Okay, and I said that assembler is used to what? To compile an assembly code. Now this one zeros one is the word interpretation of this printf, of all this thing int main printf I love programming. So this is the interpretation. Please, if you can hear me and you can see my board and you can see my screen, please do away with the board so I can have the board all to myself. Thank you. Faith, can you hear me? All right. Alabi, can you hear me? Thank you. Alabi, can you hear me? Okay.
Yes, I can.
Okay. Can you move your cursor from the board, please? All right. So now, look at it. Int main printf I love programming. This is the when I compile the code, into machine code. Look at it. It give me ones, 111 000 111 000 like that. Okay. So this one has been now compiled into machine code, what my machine understand. Okay, what my machine understand. Okay, now after it has been compiled what my machine understand, machine will now do the necessary thing After it's done with the necessary thing, then mash, then it will now transfer it to linker. Linker will now link this code here, this this 111 000 like this, now link them and convert them to what human being understand. Okay, it now convert it to what we understand. Now we want to what see I love programming on the screen. Okay, so obviously if we print out, we cannot say 111 000 because we confuse what's going on. Okay, so that's why that's the help of linker to now help us to link it and what and interpret it the way we human being understand, and link it into an executable file, which is your dot slash a dot out, or window dot slash a dot execute. Okay, then we now output I love programming that we human being understand. Please, do we understand the what I'm trying to explain? Please, do you understand this?
Yeah, I've been following. Yes.
Awesome. Now, so this is just an overview of of bit manipulation, like sorry, of the reason behind bit manipulation. One and an overview of what our machine understand. Now let's now go in depth. Let's see bit manipulation itself. Okay. Now so far now we have understand. Now let me put bit manipulation. Now we have understand, at the architecture, we have understand the reason behind bit manipulation, that our sorry that behind bits, that our machine need to understand ones and zeros, right? Ones and zeros. So now it will be easy for us to now move ahead and understand how we can now manipulate those bits, how we can now interact, speak, communicate with machine based on what we understand. Okay, right now I don't want to write my code in the higher level language. I want to speak to machine itself in what language you understand. As I'm speaking now, I'm speaking the language you guys understand. Okay, if I'm speaking my own language now, I'll be like, what am I saying? Okay, but for me to what communicate with you guys, I have to speak in the language you guys understand. So right now, the bit manipulation here is that I want to what manipulate bits. I want to speak directly with my machine. I want to talk to my machine on a what, like literally, let's talk. Okay, that's the manipulation we are talking about. Okay, we are manipulating the bits. Okay, so now the things to to understand in bit manipulation, um bitwise operator. So bitwise operator is the let me just say let me say engine now, or the brain, okay, behind the manipulation of bits. Okay, because without bitwise operator, there's no way I can speak, I can communicate with my machine based on its what language. Okay, so that's bitwise operator give us the ability, give us the power to talk, to communicate with machine. So business operator, we have first thing, we have and sorry and and okay, we have or. So let me use capital letter and. Okay, um we have XOR. Okay, XOR. We have um so the XOR, let me just put the sign that is X OR. Okay, we have left shifting, left shifting, left shift, and we have right, and we have right shift. Now, so these are the basic thing we are like we have, that these are the things we can use to manipulate, you know, communicate with machine in ones and zeros. Okay, very very interesting, right? We have and, we have or, we have X or, we have left shift, we have right shift. Five of them. Five of them. Now, so I'll be explaining this thing in easy way that we can all understand. Okay, I'll be explaining in a way we can all understand. So let's start with and. Okay, let's start with and, right? And now I want to do something real quick. This is Bitwise and, right? Bitwise and. And now I want to explain it with um I want to explain it with ternary and. Okay, ternary and. Now when we say bits, bits, 8 bits make a byte, right? 8 bits make a byte, right? Now for ternary, for our and in ternary, or for our and ternary or ternary, negate ternary, all those stuff. Let me just put it side by side here. So I want to like this, can we all see my screen? Please, can we all see my screen?
Yeah.
Okay. um
Yes.
okay. Ternary, right? Ternary operator. Now, bitwise operator is used um to manipulate bits, to communicate with our machine in the language my machine understand. Okay, that's the work of bitwise operator. But ternary operator is your normal operator, your higher language operator. Okay, that you can use the program you can write in the way you understand. Okay, you understand, is ternary operator, and ternary operator will always give you bytes, will return in bytes, while bitwise operator will return in bits. Okay, will return in ones and zero. Your ternary operator might return maybe true or false, true or false. True, you understand what true is, you know what false is, but your machine does not understand what false is, what true is. Okay, so the bitwise operator is just mainly for what, for the bits, while ternary operator is mainly for the bytes. Okay, now in our, what's it called, in our ternary operator we have and, right, which is for the what, for the and. Okay, we have we have or, which is what, for the or, for the or. So we have our negate, our greater than, equals to, less than, equals to, you know we have what's it called again, our negate, right? Not equals to,
Not
right?
equals to.
Right. uh Let me call it not. Then let me use this one, less equals, less equal. Right, this one is greater equal, greater equal, right? Now, so note I said this is what, is in bits, why this one is what, the bytes. Bytes, bit, they are different thing. Okay, byte is what we understand. Okay, Bit is what computer understand. So let's move on so that we get it now. So for the bitwise and now I'm going to do for the ternary and. Okay, now I will do this ternary and first before that bitwise and. Both work same way. Okay, ternary work same way bitwise work. They both work same way, same way. Okay, but the difference here is ternary will always give us, we always return bytes, while bitwise will always return bits. That's the difference there, but both work exactly the same way. Okay, now if it is if it is okay, in one means true and zero means false, right? We all know that one means true and zero means false, right? Now one, if it is true, one, okay, it will be what? True, right? Because both are true. Remember, and operator, if both sides are true then it will be true, right? Now if this is 0 and this is 1, then what will happen? If both sides are true, remember, note that if both sides are true in and operator, it will be what? True for ternary, right? True. And if one side is false and the other side is true, then it will be what? False. Okay, false, false. Now if here is 1 and here is 0, okay, it will be what? False, because both sides must be true. And if it is 0, 0, it is sorry, if it is 0 and if it is 0, then it will be equals to what? False, because 0 means false, right? Now if both sides are true, one means true. So if both sides are true, it will be true. But if one is true and the other is false, then false automatically. If one is false, one is true and the other one is false, false automatically. Someone saying something? Okay, so if it is what? If both sides is false, then it will be false. Okay, as you can see, this one is giving me what? It's giving out in what? In bytes. Because now look at it, I check it with bits. 1 1, right? 0 1 1 0 0 0. These are bit formats, but it is returning back to me in bytes. Remember, how many bits make a byte is what? 8 bits. So right now, so let's assume that all this now is what? Make like we have 8 bits of 1 here. In this, let's assume that, like, let's be saying that we have what? 8 bits of ones here. Okay, and both sides are true, so it's going to return what? Return byte, which is what? True, the one we understand, ternary operator. Now let's now look at bitwise operator.
Sorry,
Bitwise
please come
operator.
again.
You said?
Please come again on that.
Okay. I said, now if both sides, now I said that one means true, okay, and 0 means false. One means true and 0 means false. Okay, so I'm not saying that if both sides, okay, if both sides are true, then automatically it will be true. But if one side is false and the other side is true, it will be false. Okay, so as you can see now that this true here is in like now you understand this is it is readable. It is in it is in human readable format, because I can read this true, false, false, false. Okay, Now this, I'm not saying that we should all see this one. You know, I said that 8 bits make 1 byte. 8 bits make 1 byte. Don't worry, we're gonna see that in seconds. Okay, don't worry about that. Now this one here, okay, I said that whenever we are using ternary operator will always return bytes. Okay, we always return bytes. That is why we're having our true here. Okay, 1 1 give us true, 0 1 will give us false. Do you get that? Hello, are you still on the
Yes, we
call?
do.
Sorry, I'm sorry. I'm trying to understand this your explanation. I'm trying to understand the part where you said 8 bits give us a byte. So I don't know how it actually relates to this.
Okay, okay, okay. Right now, don't worry about that 8 bit byte. Okay, don't worry about 8 bit byte right now. Just focus on this. Do you understand this first?
Yeah, I understand
Okay.
very well.
Now, the 8 bit and the bytes, don't worry about that. You will see that when I'm doing when we are doing calculation, you will see that. Okay. Don't worry about that. Okay. Now let's move on. Bitwise, right? You know, I said that both work exactly the same way. Exactly the same way. Now, we have one and one. The answer automatically be what? Will be one. Will be one. Okay? Will be one. Now, here, you know, 1 1, it gave me true, right? You know, ternary operator. But with bitwise, you know, I said bitwise is what? Is manipulating bits. Manipulating bits. Now 1 1 will always return 1 because 1 1 is true, then it what? It will return 1. Okay, it won't return true as this one is returning true. Here we return 1. Okay, here we return 1. If I have is 0 is 0 1, okay, it will return 0. It will return 0. Okay, is 0. If I have 1 is 0, then it will return what again? It will return 0 because we have false here. 0 means false and 1 means what? True. Then it will be false. 0. Okay. So if I have is 0, oh sorry, if I have is 0 is 0, then it will be 0. It will be 0. As you can see, so with bitwise and with bitwise and, okay, whenever you have 1 1, it should be 1. So whenever you have 0 1 is 0, that means false. Whenever you have 1 0, false. 0 0 is 0, I mean 0 0 1. As you can see that both are what? The same thing, but the difference here is that this one is returning true.
Sorry. Um,
Okay. Hello. Hello.
I have a question.
Yes, ask your
In
question.
those quiz, yeah, can you hear me?
I can hear you.
Can you hear me?
I can hear you.
Can you hear me?
I can hear you.
Okay. In those quiz questions, there were some of them that had several numbers. You know, you're using one and one, bruh.
Yeah.
I don't know if anyone can hear me very well. I think his network is glitching.
Yeah, I can hear you clearly. I think his network is having issues.
I
I
can
can
hear
hear
you
you.
too. Can you hear me?
Okay. Let me see if you.
Hello?
Eric, Mr. Eric, can you hear me now?
I can hear you. Can you hear me?
Okay.
Yeah, go
So
on.
as I was saying,
Am I
in those
audible now? Can you hear me
questions,
very
you're
clearly
using
now?
zeros and ones for. Whoa. Yeah, I can hear you.
Okay. Now go
Yes.
on.
Oh, his network has timed out again.
Hello?
Okay, in those quiz questions, because yeah, you are using zeros and ones here.
Yeah.
In those quiz, there were different multiple numbers there, and all of a sudden they returned another number. I would love to like using this bitwise, maybe
Yes,
go in
we
depth
will do
because
that. We will do
I
that.
was more confused.
Can you hear me?
Yes, I can.
Yes, we will do that. I'm just trying to lay the
Okay,
foundation first before we enter into that.
okay, okay. Sorry.
Okay? We'll do that. And we'll do that now. Okay? Now, if you don't understand how this thing work, then you won't if I enter into that, you won't understand anything at all. So you have to understand how this work first. Okay? How this thing work first before that. That now this and because I'm going to use this now exactly in a program now, like in a like solve a question and you see it. Look at it. We have one. I said if we have one, it will be one. If it is zero one, it will be what? Zero. If it is 10, it will be zero. It will be zero zero, it will be zero. Okay? Do you understand this before we start? Before I move on?
Yes, I do.
Awesome. Okay, so now let's see example before we do the or and XOR. Let's say let me just put example of example of bitwise and. Okay, now let's say for instance I want to do 4 and 7. Look at it. I want to do 4 and 7. Okay, to a layman be like 4 and 7, what do I what do I mean? Okay, to a layman be like, okay, that's why it's 47 because 4 and 7, that means 4 join with 7, then 47. Okay, to a layman be like, what's this? Okay, but to you that you understand how bitwise work, okay, how base one and work. Okay, so the first you're gonna do is you have to convert these 4 and 7 to their binaries. Okay, you convert 4 to its binary, 7 to its binary, then you now perform the bitwise and on it. Okay, so let's do a simple calculation on how to do just that. We like to use, if you could remember then in our secondary school, they teach us how to convert to base, it's not base 2 now, base 2, base 10, all those stuff, base 8, you know. Now let me have my 4, then here, let me have my 2. Now 2 in 4, we give me that is 2, right? Remainder 0, right? Now the second thing here is 2 in 2 will give me what? 1, remainder is 0, right? Now 2 2 in 1, 2 in 1 will give me what? Is 0, right? You give me is 0, remainder. You remember our stuff in secondary school, remainder 1. Okay, look at it, 1. And if I you have to go from bottom to up, you know like this, right? So our 4 binary of 4 will what equals to 100. Now we got 100 for the binary of 4, right? Now the guy, are you see here, the guy that asked a question about bit, byte, all those stuff. Hello, can you all hear me?
Um, I'm, I'm fully here.
Awesome. Now this is where I want to now perform the bit bytes of a thing. Now for a what make a byte? Now this 4 is a byte. 4 bytes. Okay, this 4 is what? 4 bytes. This decimal is 4 bytes. Now for me to, now this 100, now this 1000 here, this 100 does not what give me a byte. Okay, it's not even move close to half of it. Okay, so for me to now get this 4 as a byte, then I have to have 8 bits. 8 bits. So inside one byte we have 8 bits. Okay, 8 bits give us a byte. Okay, so for me to get this 4, then I have to complete this guy to what, to be 8 bits. Then my final answer for 4 will now be equals to, that will be 0000 for is 0100. That is 1 2 3 4 5 6 7 8. That is what, 8 bytes give me what, 4 give me what, a byte, a byte. Now but this 100 here is the what, the binary of 4. Binary of 4. So for me to complete all this, I have to include all these 00, and I have to complete the cycle. The cycle, I have to complete this, the all the missing, all the spaces that are not, all the spaces I have to fill them with 0. Okay, that's why I have 40 is 0 100. So now this word is what is a bit for 4. The binary interpretation of 4 is 000001000100. Do you understand that?
Sorry. Um, does that mean that, like, sorry, you said 4 now is a byte,
Yes,
right? Like this 4 as a number is a byte,
yes, yes,
right?
yes, yes,
Okay. Does that mean that every single number, every single number is a byte?
exactly. 7, this 7 is a byte. If I have 20, 20 is a byte. If I have 100,
Is
100
a
is a
byte.
byte. Okay.
So it takes 8 bits to
Yes,
make a byte.
yes.
So there's a distinct difference between a bit, a byte, and a binary.
No, no, no. Binary is the bits we are talking about. Binary is the binary is 0 and 1. Okay. Yes. Binary is 0 and 1. Bits are the 1 and 0. Is that clear? Now
Okay.
all this now, all this, let me just highlight it. All this from here to here is binary, but single of it is bits, is a bit. Do you get that?
I understand. I understand now.
Awesome.
The binary is the computer representative. Like
Exactly.
that's what you see in that's what you see in the machine. You won't see four,
Okay.
but this is what you will see.
Exactly.
Okay.
So this is what
Zero
we
zero zero
see.
one.
Okay.
Yeah.
This 4
That's how it's
is the
represented in the
bytes.
computer.
Is that fine? Can I move on?
Yeah. Move on.
Okay. What about the guy that asked me about this calculation? Are you see here?
Here.
Awesome. Okay. Now we have seen, we have calculate we have seen the binary of 4. Okay. Binary of 4 is 0 0 0 0 0 0 1 0 0. Okay, that's binary of 4. Now let's calculate for 7. 7. Okay, 7 7 7 7 7 7 7. Right? 7. So yeah, let me use 2. How many 2 can we see in 7? Please, I want any response. How many 2 can we see in 7?
But sorry. Before you proceed, but why using
Three.
these two?
Okay, hold on. What do you say?
I say before you proceed, why using two? Can't it be
It can be any number,
any
but
other?
I'm just like the simplest number that can go. That is simplest, like this the the smallest number that can go in 7. So if I should use 4, 5, they are big numbers, and I will have to be breaking them down. Now I have a long stuff. Even if I use any number, I will say I arrive at the same answer. Yes, Lekan, please speak.
Okay. I thought the reason why we are using two is because we are converting it to binary, and binary is in base two.
Thank you. Yeah, that's the best explanation. Do you get that?
Yeah, very well.
Yeah, thank you. Thank you, Lekan.
Because
Abi
I know that
Alabi.
decimal is in base 10,
Yes, base
while
10,
hexadecimal is in
base
base
16.
16.
Yeah. Thank you. Thank you for that explanation. That's clear the air. Thank you very much. Now, 2 in 7 give us 3 remainder 1. Right? Now, let's move on again. 2. How many can we say in 3? That is 1, right? Remainder 1. Am I still audible? How many
Yes,
2?
you are.
Okay. How many 2 can we see in 1? That is 0 remainder 1. So here we have, you know, we have um we have 1 1 1. So our 7 is equals to 1 1 1. And then let me bring it here. So now my final answer for 7 will be what? 7 will now be equals to, remember the way I did it the other time, that will be 0 0 0 0 4 0 1 1 1. Okay, now 0 1 1 1. So this is the binary of 7. Okay, this is the binary of 7. Now let's now calculate our 4 and 7. Our 4 and 7. Okay, there's where this is now getting interesting. Okay, let me just copy this guy, copy that guy here. So let me put this one here. Please, can you take your cursor? Thank you. Then I put it here. Are you see here the arithmetic guy? Let can speak.
It was a mistake. Sorry, please.
Okay. All right. Now we want to perform bitwise hand, right? Bitwise hand on this. Okay. Bitwise hand. Now I will take us back to this. What I say, if one is what? Please, I need a response. One is what? If I have
It's one.
1, yeah. So 0 1 is 0, 1 0 is 0, and 0
Zero.
0 is
Zero.
what? 0,
Zero.
right?
Zero.
Now let's now come here. Now we have
Yeah.
the first one will be what? Automatically 0, right? 0, right? zero, right?
Zero,
Zero.
zero,
And
zero,
this one will be what?
zero,
Zero. Now this one will be what? One, right?
zero,
One.
one,
Then zero, right?
then zero,
Zero
zero.
zero.
Zero. Look at it. Then this what? 0 0 0 0 0 1 0 0 will give us what? Now, before we can now get our final answer, okay, let me take us back to our secondary school or our primary school. I like taking us back, right? Sorry. Let me quickly take us back to that time when my teacher will beat me for this thing. Imagine. One, 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 1 2 3 4 5 6 7 8. Remember then, if they ask us to convert this thing to base 10,
Hello, mommy.
to base 10.
Good afternoon.
Sorry, can you mute yourself? Okay. Now, remember then, they ask us to convert this into base 10. What we're going to do is, the first thing, if we could remember then, we now have raised to power, start from 0, right? 1, am I communicating? 2, 3, I'm raised to the power of what? Of 3. I'm raised to the power of what? Of 4. I'm raised to the power of 5. Of 5. I'm raised to the power of 6. Look at it. And I'm raised to the power of 7. Are you guys with me? Hello?
Yes.
Okay. Now, if you could, then if you want to convert to base 10, then base 10 means your decimal number. Your 10, your 4, your 6, your 7, your 1 are base 10, decimal number. Okay. Now, look at it. 0 1 2 3 4 5 6 7 7. Okay. Now, anything is power. If you remember law of indices, anything is power of 0 is what? 1. Right? Anything raised power of 0 is like what we're gonna do here is it will be, if you can remember, that will be 2, right? That will be 2 raised to power what? 7. Sorry, 2 raised to power 7, 7, right? 2 raised to power 6, 2 raised to power, power 5, 2 raised to power 4, 2 raised